I'm Anil Kumar, sharing with you solution of question number 15, page 129, Nelson, vectors and calculus. This is for my subscribers. These days I'm making videos only for my subscribers just to maintain the request level. The question here is, the position time relationship for a moving object is given by s of t equals to kt square plus 6k square minus 10k, everything multiplied by t, plus 2k, where k is a non-zero constant. Show that the acceleration is constant, find the time at which the velocity is zero, and determine the position of the object when this occurs. Now, this question requires a lot of calculations. I will do some, leave some for you. But I'll teach you the way it should be solved, okay? So let's begin with the position function itself, which is s of t equals to kt square plus 6k square minus 10k times t plus 2k. First step in higher order derivative is find all the derivatives required. So here we need to find velocity, which is derivative of displacement. So that will be k is a non-zero constant. So 2 times kt, derivative of the first term, plus here we have t, all this is constant. So it will be 6k square minus 10k, and 2k is constant, so the derivative is 0. So that is the velocity. If you look at the question, it says find the time at which the velocity is 0. So for that, you have to equate this to 0 and find t, right? So that's the whole idea. Now, and determine the position. So once you find the time t, you can substitute that value of t in displacement equation to find t, right? To find displacement for that time. Okay, so let's continue. Acceleration is derivative of velocity. So v dash t will be, when you multiply this, you get 2k, right? Derivative of t is 1, so we get 2k here, and this is a constant. So acceleration is 2k. Now we can answer all the questions. Show that the acceleration is constant. So what we learned here is that the acceleration, let me change the ink, is 2 times k, right? So acceleration at any instance of time for the given function is 2 times k, and since k is a non-zero constant, acceleration is constant, right? Therefore acceleration is constant, right? So that is the first part. The second part is find the time at which the velocity is 0. So that is this particular equation. We want to say velocity is 0. So we'll solve for 0 equals to 2kt plus 6k square minus 10k, right? So that is what we'll solve for. Now here is t, which you want to isolate, right? So we'll take all these terms to the left side. So we get minus of 6k square minus 10k equals to 2kt, right? You can open this bracket and divide by 2k, right? So we get t equals to, let me just rearrange everything. So I'm opening the bracket, so minus 6k square, and this minus minus becomes plus 10k divided by 2k, right? So, well, 2 is a factor here, so divide each term by 2k. So when you divide the first term by 2k, you get minus 3k plus 10 divided by 2 is 5. So that is what you get for time t. So it says find the time at which the velocity is 0. So that is the time, and determine the position of the object when this occurs, right? So the second answer for us is this, right? That is the time. Now what we can do is we can find displacement for this time. So s of, so we say, let me write down now part C. Okay, so what I'll do here is kind of make a like this. Okay, that helps. So s of time t, let me rearrange, write it as 5 minus 3k, that is t, is that okay? So we can say t is equals to 5 minus 3k. That is equals to k times time you have to replace with 5 minus 3k whole square plus 6k square minus 10k times 5 minus 3k plus 2k, right? So I would like you to solve this particular equation, which is not very difficult. You can actually take 5 minus 3k as a common factor and then solve it a bit, right? So we say S of 5 minus 3k is equal to, now 5 minus 3k is common, so we say 5 minus 3k, right, from these two terms, and here you will get k times 5 minus 3k from the first term, and in the second term you get plus 6k square minus 10k, right, and then plus 2k, right? So if you follow these steps, it is kind of simpler, right? So let's go ahead. 5 minus 3k times, open this bracket, so 5k minus 15k square plus 6k square minus 10k and then plus 2k, right? Now you need to open the bracket, apply the distributive property. Before that we can go one more step, combine the like terms here. So 5k minus 10k is minus 5k, let me write here minus 5k, and 15 and 16, when you take away 6 minus 15 will give you 15 minus 6 is 9, so we write minus 9k square, right, plus 2k, right? So anyway, just open this up and follow a few steps and get the answer. I hope that helps. So the idea here is treat k as a constant so that you're not confused about finding the derivative. Find all the derivatives, right? So you have velocity, acceleration. Clearly acceleration is a constant. And then for any quadratic equation for that matter, you will always find acceleration to be constant and velocity will be linear, correct? So that is what you are expecting, and I hope that helps. I would also like you to share with me your test papers so that I see what you are really doing. That will help me to guide you better. Thank you and all the best.